I welcome you all to the Spark Research YouTube channel. This is Dr. Veer Chandra, Assistant Professor in the Department of ECE. So we are currently running in this series electronics devices, and in this session we are going to take the some questions which has already been asked in GATE 2025, particularly from this course electronics devices. Right. So here is overview for this gate. Mostly the questions may come in the range of the 6 to 10 marks. So this is one of the important question. Here is the syllabus you can check. So go through these contents, and primarily if you wanted to visit, you can go through the Milman Halkia's book, right? So let's take the some questions. So first, this question, this gate 2025 was organized by the IC Bangalore, right? Okay, so let's take the question. So question number 22. For non-degenerately doped N-type silicon, which one of the following plots represents the temperature dependence of the free electron concentration M, right? So in this question, what has been asked, asking is that like first it is telling that doped N-type silicon, right? So we are dealing with N-type of silicon, means we are going to dope the some fifth group elements like phosphorus or the arsenic with the silicon, pure intrinsic silicons, right? So which of the following plots represents the temperature? Now they are asking the question, the dependence of the free electron concentrations, right? So definitely free electron concentration will increase, if you are going to dope the phosphorus inside your pure silicon. So the question is asking for dependency of the temperature, right? So options are given as per answer key provided by IC Bangalore. Your answer A is correct, this one. So in all options, if you will check, then we have to find out the concentration, logarithmic concentration divided by the the x-axis is like 1 by temperature, right? So means whether if temperature is decreasing means 1 by k naught, so 1 by t naught, so that is why temperature is decreasing on the x-axis, and the concentration, logarithmic concentration on the y-axis, in all the axes, right? So that will be our target. So how can we establish the relation? So there is relation like with the increasing temperature, the density whole electron pair increases correspondingly. The conductivity definitely it will increase. So the relation, well, like you can establish in this doping concentration, that is Ni square is equal to A naught T to the power Q exponential function minus of E divided by the KT, right? So with this relation we can establish, right? So here k is voltage main constant, T is temperature, and EGO is the energy gap at 0 Kelvin, right? And A naught is the constant independent of T. Okay, so here now if you will put the values like T either maybe the very high and very low, and like mid values, the like temperature, the 25 degrees Celsius or 300 Kelvin. So we can have the three different regions. If you will put the values here, then you will get log of y-axis is same only, that is log of n, and then x-axis is 1 by temperature. And so you will find the three different reasons, right? So first is the extrinsic reason. So in that case it is keep on increasing the concentration even if you are increasing the values of the temperature, and for normal temperature it will be constant, and again it's it will concentration will be go near to the infinity, so very high for intrinsic reason, right? So that this exactly reflects your answer for needs generatory dot. So answer A is correct, right? So intrinsic concentration, this formula is valid here only. So you can you can check with the some more details about it. So partial ionization, that is reason one high, that is temperature is very low, so 1 by T is very high. So that will comes under the partial ionization, that is also called as a freeze out. So at very low temperature, there isn't enough thermal energy to ionize all the donor atoms. As temperature increases, more donor ions and N increases, right? So on a log plot against 1 by t appears downward slope. Then for reason second, that is for the constant value of the log n. So extrinsic saturation region, that is moderate value of 1 by t. So in this range virtually all donor atoms are ionized, right? And the intrinsic carrier contribution is still negligible, and so n will be nd. So since nd is a constant, so plot is in the horizontal, the versus 1 by t. Then for the last region, intrinsic region, for very high t, at very high temperature 1 by t, that will be very low, and thermal generation of electron hole pairs cross the band gap dominates, and so the intrinsic carrier concentration surpasses the doping concentration, and it will increase very high. So like almost it will goes to the infinity, right? So this is the actually the solution. So finally your option A is correct, right? Okay, let's take one more question. Question number 63. So what is the question? A non-degenerate n-type a semiconductor has 5% neutral dopant atoms. Its Fermi level is located at 0.25 electron volt. The conduction band EC and donor energy level ED has a degeneracy of 2, right? Assuming the thermal voltage is given 20 millivolt, the difference, the question is asked, that is what is the difference in between EC and ED. So conduction band, the difference in between the energy level of the conduction band to the donor energy level, right? So it is n type now, so that is definitely your donor energy level will be little bit higher, right? And lower to the conduction band. So this is your valence band, your Fermi energy level. So donor energy level will increase. Why is it increased? Because this is your n type of semiconductor, but definitely it will not touch to the conduction band, right? So we have to find out the energy difference in between the conduction band and your donor energy level. So what is the difference, right? Other things are given, so this is your question. So how can we find out? So donor energy level, like depending on the ionized neutral dopants of atom cell as well. So you can establish the relation nd plus is equal to nd divided by 1 plus gd exponential function of ef minus ed divided by kt. So exponential function ef is Fermi level, ed is donor level, and kt is your k is your the Boltzmann constant, T is temperature. So Vt is equal to Kt by Q. So that is why Vt is given, that is 20 millivolt is given. So our objective is to find the difference of EF minus ET, right? And other parameters are given. So as per answer key, your answer should be in the range of 0.17 to 0.19. So let's see. So here, the difference is given, that is 5%. Given parameters are nd is given, that is neutral ionized, that is 0.95%, and gd is given 2, and kt is the if we will kt by q you will do then 0.02, that is 20 millivolt is given, and ec minus ef, that is the conduction to Fermi is given 0.25 electron volt, right? And question is to ef minus et, right? So ef minus ed is your question. So let's see the how to solve here. So if we'll use that equation, the previous equation, so that is nd plus is equal to nd divided by 1 plus gd exponential function of ef minus ed divided by kt, here it should be kt. Then if you will put all those values, you will get the value ec minus ed is equal to here ef no, ec minus ed is equal to, right, 0.18 electron volt, right? So let's see the details calculations for this particular equations. So this equation you have to use, and here gd is given, kt and ec minus ef, all these parameters are given. Just put these values, nd divided by nd plus divided by nd, that is 0.95, and put the values, and 1 plus twice it is already given. So put the values and you can get the exponential function, this one. Now in order to break this exponential, we can use the logarithmic. So if you will take the logarithmic, exponential will go out, and the log values you can get these values. So further you can get the difference, that is ed minus ef is equal to 0.0728, right? So once we'll get the difference in between ed minus ef, then after that we can find out the difference in between ec minus ed, as already EC EC minus EF is given, that is 0.25, and ED minus EF that we already got, that is 0.0728. So final the difference, that is EC minus ED, will be 0.17, that is approximately 0.18, right? So that is your answer key. So that's all in this session. Thank you to Zain. We will see some more question in our upcoming session, right? So thank you.